Should be live now, hopefully. Someone will have to tell me. I'm just going to stare at the chat now because I think I've pressed all the right buttons. Have I pressed all the right buttons? Finally. Thank God. Okay, so it was difficult. It turns out live streaming is really easy on the stream now bit. But then there's this other section where in events you have to preview the stream first and then click go live now. So I thought just by clicking the stream thing it would have been fine, but turns out not. Anyway, you missed a bit because I started talking and didn't realise you weren't here. So what we've got on the desk here is a project I've made before. It's this little LED matrix. Now I've got to press the right button. Is it this one? Might be this one. It's difficult to see actually, isn't it? There we go. And let's just shoot. Oh, hang on. Just turn this light off. So it's a little, it just wants to adjust, doesn't it? You might have to, how am I going to do this? Okay, it's very difficult to show you. This is very visible in normal light. Is there any way of me, that's kind of more visible except it's upside down for you. There we go. So it's a little guy smiling and whatnot. Let's just press this button. That resets. Okay, I haven't labeled the buttons. And this one changes the mode. So this was a little LED matrix I made a while back. I didn't debounce the button, you'll notice. Let's just change it again and again. And it's got 3 different modes. So I thought, and that's just because I programmed it that way, it's not hardwired into 3 different modes. So I thought we would, if we get time, after I've done the primary thing, we'd play with this. I just wanted to explain why this was flashing away on the desk. So let's get this out of the way. Today we're going to be making this, which is it's a power multiplexer essentially. So this is the TPS 2113A. The PWR I think just stands for power. And I've had some boards printed, and so I thought we would do this. Now I may have made a small mistake. In that one of the parts is a 1206 footprint, and I only have, what are they? I only have 1K in 1K resistor, which is, it's the one that I've highlighted here. I've only got that in 0805, so we're going to try and squeeze it on that pad. That's the 1206 pad. So 1206 is a bigger footprint than the 0805, so it's the 0805 is a smaller chip, a smaller resistor. Oh yeah, ignore that. We'll look at the matrix a bit later, so don't worry about that too much. Yes, Exos Dell. Yeah, it was the on button that I'd missed. It said the stream health was good, and I sort of took that to mean that it was working, but obviously not. Anyway, this is the circuit that we've made or had printed up, and this is the actual board. So let's just press the rat's nest tool on this. So we've got a very fine pitched IC here. I don't know what the footprint is. Let's see if it says it on the packet. It doesn't, but I can look it up. So let's find out what that is. TPS 113 PWR. Would help if I pressed the right things. Let's find out what the package is. I think it's it looks like SSOP, but it looks smaller to me. No, it's a TSSOP-8 pin. So it's an 8-pin device. Does it say that wrong? Shush. It does say it wrong. Ignore that. So we're using a mini USB, which is kind of a lame, let's see if we can find one. Oh, there we go. It's a lame old sort of standard footprint, really. Not footprint, connector. I'll try and get a bit closer in on this actually. Let's do that now. Just move some of this stuff out of the way. Oh, first off, let's turn this light back on so you can see better. Ignore the juddering. This camera's on some helping hands at the moment, so that's why it's juddering around. So these are the boards that are printed. So you can see that that tiny footprint just here, or on this one is a bit easier to see. Tiny footprint. That's what that one is. TSSOP-8, and we've got this USB. Is it? Oh, what was it? USB Mini Type B. So that one, sort of, if I get it the right way around, that just sits on that one right there. So it has little studs on the bottom, and there are some drill holes in here. I don't know whether you'll be able to see them, hopefully. Some drill holes in there to place those into. So we're going to be soldering this up. I have got a little USB holder, a PCB holder. USB's on the brain now, that we can place this into, and I'll need to arrange this a bit better. So what we'll probably do is start off with the resistors, because they look like they're pretty close to everything else, and so they're probably the most sensible to start with. Mr. Friesberg, is that how you say your name? Why not micro USB? Well, I bought a lot of these USB minis, and so I kind of want to use them up. Plus, I have a lot of USB mini cables, and USB micro. The only real benefit it offers, apart from being slightly smaller, is that it locks into place. And I think I should just use these ones up, really. But USB micro, no problem with it at all. That's the real benefit of it. It locks into place, and it's not even really a smaller footprint, because once you get it on the board, it's still just as wide. It's perhaps just shorter, that's all really. I suppose it's not as tall as well, so there is that. Yeah, I just do have a lot. So I'm going to show you not a trick to SMD soldering, but I turn my soldering line on actually. It's not a trick, but it is a tip, I guess. Now, what we're going to start with, I'm going to have to use this PCB layout to tell me where I'm putting things, because I sort of end up forgetting. And we're going to use our multimeter to make sure that the resistors are the right value, because I try and keep them in these little packets, but often they get mixed up. So if my eyesight's good enough to read the number on the smaller ones, then we'll be okay. But otherwise, we've got a multimeter on hand. So we're going to start off with, I kind of want to start with that one. So let's flip this one around. I'm going to start off with resistor 2, which is a 470 ohm resistor. So I'll jump back to the desk. So we're going to do this one just here, which is 470 ohm. So I've got some of these. Oh, hang on, these are 0805, so I don't want those. I want 1206 470 ohm resistors. Now, I use 470 ohm resistors a lot. They're generally the ones I'll use for LEDs. I don't like to run LEDs at their full whack. Generally, I mean, for most LEDs, that's going to be 20 milliamps. I prefer to run them at a lot lower value, because it not only does it extend their life, it means that, and they're still very bright enough for most purposes, but they also means the power requirements of the circuit are reduced. And on the little LED matrix board, this one here, I'll be using 470 ohm resistors to reduce the load on the 748C595 shift registers. That are, I mean, people will criticize me for this, but I'm using those to drive the LEDs. So the maximum current, I think, for a 74HC595 is around 25 milliamps. So that's the output on all of the pins. So not even individual pins, I think that's collective. So I'll be using that higher value resistor. We might even change and look at using a 2K maybe and see if that will light an LED, but we'll test it first. Okay, so let's get started. So what we're going to do is just solder one of the pads first. Now this is the easiest way. Let's see if I've got some tweezers somewhere. I'll need some of those. Is this appropriate? No, those were rubbish. Let's see. That one looks like it's going to be okay. Let's see if I can pick up the resistor there. Yeah, that's fine. These tweezers will be okay. So first off, clean off our soldering iron a little bit. And then we're going to apply solder to one of the pads. Now I'm going to choose this one here. Hopefully you guys can see. So I'm just going to heat the pad a little bit and apply a blob of solder. Now I don't need to fill the pad. I'm only looking to be able to get enough solder on there to push my LED, my resistor on. So if I just drop the resistor on there, and then we're going to heat that pad again whilst pushing this resistor into the pad. Ah, son of a gun. Now I'm sort of awkwardly arched over, so my hands are shaking a touch. Don't. Plus I am live streaming at the same time, so it's not all that easy. So just going to melt the solder a little bit, leave it. It should settle just fine, so that's done. And then we're going to swing this around a little bit just so I can get a better angle. Just clean that off a little bit. And then we're going to heat that up again and fill up that pad. Done. And now we can go to the other side again and pop a little bit more solder on there. Not too much. Doesn't need a lot really. We're not looking to flow underneath the pad exactly, underneath the resistor. So let's see if I can, will it focus that close? It will. So that's essentially what we're looking for. That to me is a perfectly fine SMD solder joint. If we were doing this in a different way, using solder paste or something, I would expect a cleaner joint, but it's a little bit raised, but it's certainly connected. Like there's no way I'm taking that off, so it's going to work fine. If anything, more solder creates more sound electric joint. So I'm happy with that. So we'll move on to the next one, and that's a 100K resistor. And that is over the other side here. In fact, let me just break off these little tabs that are on the side. Just going to snap off these little tabs. These are from when the PCB was manufactured. It just doesn't make it very easy to put into this PCB holder. There we go. I'm not sure I told you what this thing is, did I? I may not have done. So the TPS113 PWR is a power path multiplexer, and that essentially means it takes two inputs, two power inputs. So it could be, essentially in this case, is what the use case for this would be, batteries and USB power. So you would have, it don't even need to be two separate voltages, but they can be the same voltage, it's fine. It's going to prioritize one power path over the other. And then when one power path drops below a certain voltage, or when it drops below a certain voltage or lower than the other voltage, it will switch to use the other power path. So it's like having a UPS, uninterruptible power supply. And I'm hoping it will work with a Raspberry Pi. However, I haven't tested it, and the company that I bought one from, and if I can find it in a second, I will show you the actual module. In fact, let's do that now. I think that's probably a good thing to look at. Is I bought one of the modules myself, and I thought, hey, I'm going to make one of these because it seemed like an interesting project to do. Are you in here somewhere? I would have thought you would be in this little bit there. He says, after having just sorted all of his electronics out the other day, there it is. So this is the, God, I really hope I can, I'm not sure that's the one. Anyway, we're going to see if we can solder it. So that, that is the module that I'm emulating here. This one's got more pins, you'll see, and it's a slightly different form factor. This one's designed for a different purpose, really. It's designed so that you can customize it in lots of different ways. So if you want to use it as something that you can manually switch between power inputs, you can connect a button to VSNS, which is somewhere on the board there, and ILIN, there's VSNS. So these separate pins allow you to change the behavior of the chip, but I just want it for one specific purpose, to be an uninterruptible power supply, and so that's how I've set it up in my schematic. In fact, I can probably try and explain some of that schematic to you before we go too much further. I'm just going to look at once those small tabs on the PCBs are ripped off. Well, you've got your wish. So this is the schematic. It's not the standard one out of the data sheet. In fact, do I have the data sheet? I do. So here's the data sheet. In fact, let's, can we make it larger? Let's see. How do you zoom? Ah, there's a button there. So the datasheet has some examples in here, typical application actually. So VSNS will go to a PWM signal. So if we jump down to some of these examples, so there's a duty cycle there. Is that what it is? No, I think I'm looking at this wrong, hang on. Let's look at the truth table. That's really what I wanted to show you anyway. We'll jump to that. Truth table. Truth table, there we go. So this sort of hinges on the VSNS pin. And I've connected mine to ground. So the answer is no for that. So in the truth table, we're going to choose one of these two options. And so if V in 2 is greater than V in 1, it will kick out one of these two voltages. So if V in 2 is not greater than V in 1, then on the output we'll see V in 1. Now V in 1 on my device is hooked up to the USB. So the USB is the preference. So we want USB to be used if it's there. And if the USB voltage, the in 1 voltage, is lower than in 2, I'm going to get confused soon, then in 2 is the one that's used. We also have a stat pin, which I've broken out, but I don't know if I'll use. So you've got, it's either grounded or it's high Z, which is low impedance. Is it? No, high impedance, sorry. Idiot. Anyway, we don't need that. So essentially that's what the schematic is showing us. We've got an LED to say that power has been applied to the USB. I'm not shorting out the data pins because I don't think you necessarily need to on most devices. We've got some output capacitance here, so decoupling on the output, and we also have some decoupling on the inputs. Now I've popped those on that part of the schematic because they just wouldn't fit here, because I knew I had to come around here. So they sit over there, but they're still connected to the same part of the circuit. All right, let's solder a few more bits up. God, I've got a coffee here rather than beer, but I put some whiskey in it. It's not very nice. I put too much in. Okay, so what are we going for next? Was that 100k, wasn't it? And that was this resistor here. I think that's correct. Let's check. Yeah, that's a 100k resistor. So what have I got? That's 100 nanofarad. That's not what I'm looking for. 100k 1206. So this one here. So I buy a lot of SMD parts from Farnell, and that's mainly because they have free delivery on orders over £20, and they have everything. And they're pretty cheap too. I mean, it's cheaper to buy them from China and get them bulk delivered, but you can get them next day delivery from Farnell, so that's quite nice. So it's these pads here that we're going to be soldering to. And again, I'm just going to solder one pad first, and we'll choose this one so that we're not pushing it onto the board from the other side. Don't need to put a lot on there. And we'll just push it onto the pad, let it cool, and then let go. And that should be, I'll show you the halfway point. So that's what we're looking for. There's not a lot of solder onto, let me just hold this steady. So there's not a lot of solder on that pad, you'll notice, and it could do with a little bit of movement. That doesn't look too clean, does it? But you know, you buy boards online that have worse worse alignment than that. So I'm just going to leave it. That's fine by me. I'm not obsessed with things like that. So I'm going to shift that board around so I can get to the other side. Difficult for you guys to see what I'm doing here, but I'm going for this side here. There we go. And then I'm going to bring it back round and solder the other side. We will test this board. I don't really have a good test for it. I've got some batteries, I've got 4 AA batteries, and I've got USB to plug in, but I don't really know what to plug into the output. So if anyone's got an idea, something that we'll be able to see whether it loses power or not. The output capacitance on those pins, we can put something on the breadboard so that we can test it properly, but I don't know what's really going to be ideal. So next we've got something in the middle that looks like a capacitor. No, it's a 1K. Oh no, we're not doing that yet. That's the one. The one in the middle is the 1K resistor. Should we get a bit closer? Is that going to be helpful? How close can we get? Holy moly, look how close that is. Okay, are you guys happy if we do it like that? Is that all right? I'm going to guess yes. I don't know if you've got there yet. Chat's always behind a bit, isn't it? Anyway, what's the next one after that? We need a 1 microfarad capacitor. Let's see if we have some of those. That's 100 nanofarad. 1206 100k resistor. That's not what I wanted. Now I'm sure I had some. $10 microfarad. That's not the one I want. I need 1 UF. Okay, I'm just going to have a look in the parts drawer to see what we've got. Actually, I put some on the floor, so maybe they're down here. 1 UF. It's easier to say than microfarad. These look like all resistors. 150k, 10. Do you think it's actually a problem? I think I might just use 10 microfarad. I don't think it's going to be an issue. Do you know what? We're going to use 10 microfarad. All right, I'll check in the datasheet first. We'll have a look in the datasheet, shall we? Right, so output capacitance. Let's see if it's got some advice on that. Sorry, I'm sort of zooming super quick. There must have been a reason I chose. Oh yeah, I chose 0.1 UF. So that's 100 nanofarad. Okay, we can do that. All right, I've chosen something different. Screw it. Okay, we'll do that instead. Let me just jump onto this board and we'll just change these. Maybe I meant to do that and I just mislabeled it. So we'll put 100 nanofarad in. So, as always, making mistakes. So they go just there, which on my board is the furthest along, and then another one is there. So 100 nanofarad, 100 nanofarad, and that is our polarized capacitor. And then after that, we've got the frightening one there. So that one and that one. And it doesn't matter which way around they go. So we'll just jump back to this. Someone suggested setting the focus point. So I can do that. I can turn off autofocus. Oh look, actually got some control over it there. I think that looks reasonable, so we'll leave it there. So it's manually focused now, so nothing else should happen. So let's just do one of the pads here. Oh, I'm going to solder my my webcam if I'm not careful. And then we want, oh, where did I put them? Oh, they're just here. So I'm instead of the 1 microfarad ones, I'm using 100 UF 16 volt ones, and it should say 1206 somewhere on there, but I can't see it. Do you know what? Maybe they're not 1206, but they look it to me. So these are the capacitors we'll be using. They're the massive kind, so they're definitely 1206. I'm going to need to use these tweezers to break off that seal. Notoriously difficult to get into. Wish I had a knife or something actually. Ah, I do have some snips though, I'll do. Oh, come on now. Ah, got it. Once you got it started, then it's all right, but I've just had to mangle the end of that to get that thing open. So this is our capacitor. It's quite massive, or at least it looks it. So what we're going to do is we're going to push this one onto that pad there. So we'll start off there. And clean that soldering out a little bit. Is that straight? It's good enough. I need it to come this way though. Oh, you're right, it does say 10 UF. Let's take it off. Where's my... Okay, you're right. They are just there, the 100 nanofarad ones. Thank you for noticing that. You know, I would have gone through this whole thing and done it wrong had you not mentioned that. So thank you. Plus they're an awful lot more difficult to get off when you've soldered both sides. Saved again by a viewer. Right. So we'll be using these ones instead. These are 100 nanofarad ones. And I might just put a tiny bit more solder onto that pad. And again, we'll just push it on. There we are. That looks ugly, doesn't it? Oh well, we'll clean our board off in a bit. And then we need to attack it from that side. More whiskey is definitely needed. Thank you very much, Cheetah Kid, for pointing that out. I appreciate that. Right. There we go. That's good enough. I mean, that looks okay, doesn't it, actually? Let's just pop a little bit more solder onto this side. There we go. I don't know how much you can get in there. But I mean, there's a little bit of resin floating about on there, which we can clean off in a little bit. And then our next one is C2, which is just here. So let's do that. I realise you'll notice the the text on here is pretty terrible. It's because I did it in a rush. And then we want one more. No, we've not. Oh, I'm lifting it up slightly. There we go. That's good enough. I keep saying that, good enough. That's not really the idea, is it? It's not meant to be good enough. Right, it's a little bit close to that pole there. There we go. And then we'll come back around this side and we're going to solder this side again, because that's the one where we've just pushed the pad on, so it's not got a great connection and certainly not really enough solder. There we are. Now what's left? We need an LED. Does anyone have a preference on LEDs? Any colour? Let's see, what have we got? We've got red, green and blue, and there might be some. Let's have a look. Have we got any different colours? There's bound to be some other ones in here somewhere. Oh yeah, there are lots. Here we go. So we've got blue, yellow, red. There's probably some orange. Another little look. Green. We've already had green. Any preference on the colour? Green, 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 blue, blue, green, blue. So 1, 2, 3 blue. I think it looks like more green. Purple LEDs, please. I don't have any purple, unfortunately. So what? I should have put a poll up. 1, 2, 3, 4, 5. 5. The LED just indicates that the board has power, so nothing else. So it doesn't really matter what colour it is. I'm not really bothered. I mean, the blue LED is going to draw more current than the red LED, most likely. In fact, we could probably test it. In fact, I've got red, green and blue LEDs here. So let's take them out and look at their forward voltage and then do a little calculation based off the 470 ohm resistor. How does this thing open? Fuck it. Oh, sorry. No one heard that. Blue. So we've got, let's go up a little bit. Fixed focus. Brilliant. Let's just change that. Properties, configure, camera control. Let's just jump to auto for now. So I've got some green LEDs, I've got some red LEDs and some blue LEDs. So let's pull one out, a blue one, and we'll test the forward voltage, and then we should be able to figure out what kind of current it's going to draw at 470 ohms with 5 volts. It's not actually, it's only connected to USB, so it's not connected to the output. It's only connected so you can see whether input 1 is powered. So it's not going to pull from the normal power. So this is a blue LED. I know I need, let's get rid of the board for a moment. See if we can actually get this into shot. Yeah, it looks like we can. So we're going to go into diode testing mode. Yeah, I thought red was one of the most efficient ones, but I mean, saying that, I've got some straw hat LEDs that run at 0.7 milliamps, so they're really, really good. And in fact, I'm running something which is that solar safety thing, and that basically ran the whole thing on around a milliamp, which is incredible. So I think I've got this the wrong way around. Yeah, it's that way around. Or is it not? No. Oh, sorry. There we go. That's better. So, okay, it's not reading it. Oops. For heaven's sake. I'm pretty sure that should be giving me some kind of reading. Okie doke. I'm going to go with, what colour did we go for? Was it blue or was it green? This, let me just test this with just a blooming diode, shall I? I'm not sure which way around on the diode I'm going. Yeah, well, it can read a normal diode. Pretty sure it should be able to read an LED. Not this one though, apparently. So let's pop that back in the little pack and then we'll just try a different one. It's not like I haven't got time to do this. Let's try a red one. I like the idea of red. You guys have not even mentioned red, I don't think. Red is the colour of danger. And I don't know where I'm going with that. Let's pull these ones open. Oh, there we go. Oh, there we go. Anyone else know why my meter might not have been able to read the voltage drop across the diode there? Should be that way around, hopefully. I don't know, I always forget which way around I'm meant to go. No, the mark is always, there we go. It reads this one. That doesn't say 7, sorry. Let's just move that into view. So forward voltage drop is 1.7 on the red. And then we've got green to look at. We don't necessarily need it to be a dangerous device, so I'm not putting a white LED in there. So white and blue usually don't work. Is the forward voltage drop too high for them to read? Is it something like 2.2 or higher? Right, this one is a green LED. So I figured out which way around it is now. So the mark goes to the ground. And green also won't work. So I'm assuming the voltage drop is too high for it to read. Either that or it's taking too many milliamps to light. So I think we're going to go with red. Is everyone okay with that? Or do you still want me to go for blue or green? Let's see if I've got a different diode that's going to read quite high. I don't know. I don't think I do actually. I think these are all the same. If I read it the right way around, which I haven't. Oh, no, it's just a standard 0.6, isn't it? Ignore that. Okay. I don't think you've lost audio, have you? I think I'm going to have to go with green, which is what everyone sort of said. So that's what we're going to go for. Oh, crumbs. I've forgotten what colour these are now, and I wanted to put them back in the pack. So let's have another look. This one is red. So that needs to go back in the little red packet. I mean, there are 100 of each one, 200 in each one of these packets. So it's not like I don't have more than enough. You will get another chance to choose some LEDs if we get onto the matrix. And the other one was green. We're going for green, aren't we? So that's this one here. Yeah, okay, cool. We can put that away now. And bring back our board. And we can come back down again as well. Let's change the focus back. Oops. You going to stay there? Maybe. There we go. Okie doke. Right, now let's figure out which way this LED goes around, shall we? So it comes off the 450 ohm resistor that's just there, and then, oh, it's already got a mark, so that's easy enough, isn't it? So the mark on the LED goes to there. In fact, on this LED, actually, this is really interesting. It doesn't have, you don't have this on all LEDs, but can you see the little arrow there? Not all of them have that. I've worked with a lot, so I know that to be the case. But sometimes you'll get a line, and a lot of times you'll get some kind of indicator. So if I look on the other side, oh, come on, please now. If you can see on this side of, oh, there we go. Can you see the small green marks at the top here? Let's just spin it round. It's so frustrating when the resistors or capacitors or LEDs fly around. Jeez Louise, I hate them. So this one's got some green marks on the end here. It's difficult to see. You see those green marks? That's the bit that's going to ground. So that is the cathode, correct? Not sure. I'm never quite sure. Anyway, we need to solder up one of these pads. So let's solder up the cathode pad. Put a fair old chunk of solder in there because it's quite a chunky little chip, and it's got these little cutouts for that solder to get wicked up into. So where is that pad? There it is. So you'll be able to see me put it in. And actually, we're going to have to spin it around because I'm actually left-handed, and it becomes very difficult when I'm trying to do this with the wrong hand. And I'm now going to use the soldering iron with my right hand, which is exceedingly weird. There we go. Oh, mayday. And now we're going to solder the other. In fact, this coffee's going to get cold, and then basically I won't be drinking the whiskey anymore. So I might have to have a little break and go and get another one in a minute, because it is cold. A lot of solder on there. I didn't need to put that much on. And it hasn't even done it properly, so let's try that again. There we go. And I tell you what we're going to do. We're going to test it in circuit. So the power should come from over here on resistor 2. So this one here. Let's move this up a little bit. So the power should come from here, the end of that resistor, and it should end just there. So it'll go through that resistor, just like that. Quite bright, isn't it? Oh well, that's good enough. So now we've got one more component to do that I'm concerned about. The other one, the micro USB thing, should be relatively easy. It's this R3, which is a 1K resistor. And it's going to have to be an 0805 package. Now, I'll pull out an 0206 so you can see the difference. So this is the package, the 0805 1K. Have I got scissors here? Yes. So this is 0805, and that is 1206. So they're a different footprint. Different by which I mean it looks to be about half the size. And then I've got to fit this 0805 onto that pad there. And so you can see it will just fit, but it's going to be difficult. It's probably, I don't know, 1/4 of a millimeter to play with. Not a lot. So we're going to have to flood that pad with solder a little bit just to give us a little bit of extra room. So let's do that. I did just touch the webcam with the soldering iron. I don't know if you noticed. There we go. That's a nice bead of solder on there. Oh yeah, this webcam's not going to focus any more than that, is it? And then we're going to try. I may not talk during this section. So is that going to be okay for you to see? Yeah, okay. So where are the 0805s? They're just here. I don't mind soldering 0805s, and in fact 0603 is also okay, but onto the wrong pads, not going to be the easiest. But that's my fault for misreading what I actually had. So let's just drop one of those out. Oh God, let's just try and turn it over. I mean, we don't really need to turn it over because it's a resistor. It will work in any orientation. Oh my Lord. Oh, come on now. Oh. it will work in any orientation. It doesn't matter, but for readability's sake, I'm going to try and get it in the same orientation as every other bloody thing on the board. Look at that. Is that even going to work? It's only the width of the blooming pad. So that's what we have to do. Just got to try and push it in and hope it sticks. I mean, I can just flood solder onto it, but this is going to be difficult. Here we go. Now I just want it ever so slightly, there we go. It seems to have wicked up, and oh, we're still over this side, so we can bring it a bit further over. There we go, look, we've got some room to maneuver there. That looks okay to me. Oh, it's as if it was made for it. It was pre-planned. It definitely wasn't pre-planned. Okay, now I'm going to solder the other side. That looks big blob of solder, doesn't it, on that side now. And then I think it's probably okay. I mean, that is wonky, isn't it? Still, I am happy enough. That is all right. Next up is the USB connector. Actually, is that next? Or should we do the chip first? Do you know what? I think we might do the chip. We're going to do the little chip now. So, where are they? There they are. This is, I haven't even taken these out of the packet yet. There are two of these because I want to, if it works, I'll be building another one. If it doesn't, then I'll have to design a new one. So it comes in this little, let's move this out of the way. It comes in this little package. I bought these from eBay. I didn't get them from Farnell, despite this being quite obviously a Farnell packet. So this is the TPS thing. It's got this dispatch note down here, but it's exactly the same kind of detail you got on a Farnell one. So whoever bought it bought a big batch from Farnell, or they've got a company and they get things cheaply, and then just ordered them. I think, oh, okay. They look like little spiders. Let's get one out. So there, oh, it's not focused naturally, of course. Let's try focusing that. So there it is. That's the little IC we're going to be using. It doesn't have any, it doesn't have a thermal pad at the bottom, but that is the bad boy we'll be using. Let's have a look at it in comparison to the other board. Where did that go? I showed you that board, right? Did I put it back in the... I don't put things away. There's no way I put it back in the box, is there? It's not possible. Ah, there it is. So it isn't the same... It isn't the same form factor. Is that a QFN? QFN? QFP? Quad flat pack, this one. Possibly. I can't remember what the pinouts are called for these things anyway. We're going to be doing that. What cam do I use? I don't know if I've missed any of the questions, so I apologise. It is... I'm using two. I'm using the Microsoft LifeCam HD 720p camera. That's the one you're looking at right now. And then my face is currently sat on a tripod. Face isn't sat on a tripod. It's like the C920 Logitech thing, I think. It works well enough in low light. Whereas this this webcam down here, it means I can shine bright light onto the desk, which means it's okay. Right, I need to sort out this again. So that's camera control, auto, and then let's pick up this IC. focus. Drop that on for a sec. And then we're going to fix the focus again. Apply. Okay. Right, actually, okay. Jump over to here for a second. Right, if you can bear with me for a second, I'm going to go and get another drink because I'm quite thirsty because I'm doing a lot of talking, and I will be back in a minute. I'm just going to mute the audio so you don't hear me clanging around and such, but I'll be back in a little bit, so feel free to chat amongst yourselves, and then we'll come back and we'll solder that part. So hold on. made a bit of an error actually. When putting whiskey into the drink, I put it in last, which means you can't really tell how much you're putting in there, so this might turn into quite an interesting stream. Anyway, let's jump back to the desk cam. Is that the right one? Yeah, there we go. So, we're going to solder this small chip, this small TPS 2113 PWR. It's kind of tiny, so we need to line it up properly. Need to make sure it's lined up on both sides. Luckily, we've got very long pads on there. Really helps with lining these up. And what we're going to do is solder one pin first, then line up the rest. I am just going to grab something to help me, because it's a little bit dark there, so I'm just going to put a torch on it like that. To give me a little bit more illumination. And we don't need that there at the moment. I'm just going to put some solder onto one pad. Do I have any small? Oh, we do. For very small trips like this, I like to use kind of smaller solder. If you'll notice the size of the solder there. So this is the one I normally use, this one. And that's the one we're going to be using, just because it gives me a little bit more control about the amount of solder I'm putting on the pad. This one doesn't come on a reel though. I had to buy this just in a folded up thing. Solder is really expensive. I don't know if anyone's noticed, but good solder, good like leaded solder, 60-40 kind of stuff is quite expensive. Unless, I mean, you can buy large things of it, but then are you going to ever use all that much? So I tend to buy it in 4 meter lengths. Or is this 2 meters? I think this is 2 meters, this one. And then you just have to be careful not to throw it away or lose it, which I often tend to do. So I'm going to solder which one of these pads? I don't know what the pitch is on this actually. It is possible for me to find out. Let me get the tool. Do I have one? Let's see. I don't know if this will, it won't focus on this, but I've just got a little measurement tool. This is 0.4. Could be 0.5. I might have been squeezing it a bit too hard. I'll put the mic back on actually so you can hear me properly. I think it's 0.4. So we're just going to do the one pad. I don't know which one to do. I'll do the one closest to me because then I can properly see it. I've got a large soldering iron tip. In fact, before we do this, let's grab some flux. Flux pen, where might you be? I know what you look like. Are you over here? Yeah, there you are. So I'm just going to use one of these flux pens. Always another coffee and whiskey. This one's well used, look, you can tell. So we're just going to rub a bit on, and it should make it a little bit easier to not F it up. So there we go, we've just got a little bit of solder on that pad. That is more than enough for me to line this chip up. And now I need to make sure I'm doing it the right way around. So I'm just going to bring it up to the light a little bit and see if I can see the dot. I can. And it's around the wrong way. Oh no, Mayday. It's all going wrong. Where is the dot? I'm just going to make sure that dot's in the right place by looking at my board outline. And I'll just have to look at it from there. So pin 5, pin 1 is stat, and that goes to the 100k resistor. So pin 1 is there. That doesn't make sense. So pin 5 is ground. Pin 8 goes to in 1. Hang on, let's just try moving this IC and then let's just see if there's... I'm pretty sure it's this, let's move this out of the way. So I'm pretty sure, you see that little star there? I'm pretty sure that star indicates pin 1, but I just want to make sure because there's no way for me to unsolder this IC once I've soldered it onto the board. I don't have a hot air thing or anything, and it would just be a nightmare. So I just want to make sure it's right. So pin 1 should go to 100k resistor and to whatever that is there. So let's see what signal that is. Going to stat. Pin 1 goes to stat. Okay, yeah, so that is correct. So this is the orientation it's going to be in. So I just need to get lined up and then push that onto the pad. Okay, I think we can do this, he says. Right, you're probably not going to see my face for this because I'm going to have to get really in close. There we are. That looks, doesn't that look lined up to me? It looks lined up from here. Let's have a look on our little close inspection cam. Not quite, is it? They're slightly off. So let's do that again. And it needs to go towards you guys a little bit, I think. Maybe. Let's have a look at that now. That looks about right, doesn't it? Yeah? Everyone happy with that? I'm happy enough. Put a little bit more flux on there. And then it should be a pretty easy job just to throw these on. We could even use the big solder for this, so but let's use the little solder. Just dragged it across there, so that should be soldered up. Yeah. So the drag method essentially, well, mine's more like a shuffle it around method, but it involves me just wiggling solder all over the place. Because we've put flux on there, it pretty much does our job for us. I've just burnt myself on the coffee. There we go. Is that a solder bridge? Yeah, it looks like a solder bridge to me. But that's fine, because we can just pull that across and get rid of it. If not, then I have some of this stuff. Should enable us to get rid of that. Let's just have a look. No, hasn't yet. Okay. A little bit more flux, I think. A little bit more flux, a little bit more heat, and maybe some more of this soldering braid, desoldering braid. There we are. That's ugly as all sin, isn't it? So let's clean it off a little bit. I'm going to spray it now with some isopropyl alcohol. I can't say that. I mean, it's... In fact, let's not spray it directly beneath the camera. So I sprayed it with some alcohol, and then we're just going to sort of vigorously rub it with this old toothbrush. Yes, this toothbrush has been inside my mouth. And then we should get a better idea of what's going on there. So that side looks clean to me, and probably clean to you guys. So you can see that side. Let's turn it around and see the other. And that side also looks clean. So we've just gotten rid of some of the flux, which sort of, in this light, it makes it look a little bit like you've got a solder bridge, but in actual fact, I'm not sure I did. But those are now connected, so we are good to go. We're good to move on to I think we'll do the USB connector next. So here's the USB connector. We'll just pop that on. And it sort of slots on, which makes our job really easy, because it has holes to drop into. Just like that. And then we've got some, if I can get it in the right angle, we've got leads there which automatically line up, so we don't have to worry about that. And the easiest thing here to do is solder one of the big connectors on the side. So we're going to do that now by, are we going to put anything on the pad first? No, I don't think we are. We're not going to bother. We're just going to go straight for one of these. Now, how can I do this without you guys, with you being able to see it? There we go. Okay, I'm going to do one of these ones here. So it's probably going to be a back one, unfortunately. Just, I know you can't see it, but oops. I'm putting my finger on it just to hold it together for a little bit. So you'll see that's pretty well soldered on, and alignment wise, oh, it's difficult to see that, isn't it? Let me alignment wise we look okay there, so that should be fine. I don't need that little torch anymore. Let's turn it off. There we go. And we're going to go back to big solder now, because I don't think these are too fine. In fact, those connectors are probably quite fine. So we'll solder the rest of these up. It's important that these get soldered really well, these little joints, because they're the ones that are going to be holding this darn thing on. And I mean, it's very important for your iron to be at a good temperature as well, because otherwise these joints take a little while to do. If your iron's too hot, then your solder's not going to behave very well. Let's get a bit of flux in there. And then we'll use the small solder again. And I really hope this works. And then we've got a big iron here, so we've got to be quite careful. I can't see very well, sorry. Nope. Bit difficult to see down here. Sorry, I'm going to be well in the way of the camera maybe. How's that looking? Do they look soldered? I mean, I could bring it up to my face and have a look, but I'd really rather you guys be able to see it. They look good enough for me. Oh, do you know what? That torch is staying on. I can't figure out how to turn it off. Right, I'm going to just have a little inspection look. And the answer is no, they're not soldered. They're sitting proud, so I'm going to have to get in there and just push them down a little bit. And then give it another go. So one is soldered there. The others, I've just got solder on the pads and not on the pins. I know it's very difficult to see from this angle, but they sit a tiny, tiny bit up from the pad. And that is rubbish. So we'll try again. Yeah, I generally prefer better ambient light, but because I've got a camera directly over the board, I can't really see very well. So we're going to have to, in fact, you might have to put up with it being this side and not being able to see very well, because it means I can see it properly. Again, more flux. You can never do without more flux. And I've flooded them. I did that on purpose because it wasn't taking any solder. And now we're going to just use some desoldering braid on it a little bit. Come on now. This is going to work, I promise. And they can't see. They look perfectly well soldered from your angle, but I guarantee they're not. This isn't taking any solder. It's frustrating. Might have to flow a little bit more onto it, unfortunately. In order to get it to start wicking up. There we go. Still not right. Right, slightly doing this off camera, I'm sorry, because I need some light, unfortunately. Oh, you absolute son of a gun. It wouldn't, it would help if I hadn't removed a pad just then with the solder wick. Can you see it? Anyone know which pad that is? Do I need to worry about that? Don't think I do, really. Let's find out what pads those are. Don't think I need to worry about it. but I'm going to try and desolder it anyhow. Not desolder, I mean stop them being connected together. I'll tell you what we could do. Should we just plug something in? See what happens? That sounds like a good idea, I think. Let's do that. Right, so I need, not that. I need a, not that either. I need a USB cable. Where would it be? There it is, underneath my desk. So what I've soldered together, if you look at this, these pins were sitting quite proud. I don't know if, in fact, yes I can. We're just going to have to go up on the camera, aren't we? Right, I'll just adjust the focus so you can see what's going on. So the pins are quite proud off the board. Can you see one sitting? It's really difficult, isn't it? One is sitting off the pad, just over that side. And then I've soldered two together there and I can't desolder them. And I've also ripped a pad off when trying to desolder. But I actually only need the two outside pads, which is quite nice. So it might be that I've just soldered together two of the data lines, which is also fine. It just means it will draw more current if I need it. So it's not an issue. Or maybe it is, I don't know. Next time I'll just have to do it while paying a bit more attention. Because I was trying to do it behind a camera, it was very hard. Yeah, I've pushed down on each pin with the iron, the very side of the iron, so I was just pushing down on each one, but do you know what, I think I'm going to have one more go at using the desoldering braid on that, because I don't know what the ramifications are connecting an ID pin to the data line. It doesn't need to be recognised by a USB device or anything like that, but it sure does need to not mess up. Or do you know what? Where's the solder sucker when you need it? Not that it does any damn good, because solder suckers are terrible. Yeah, as predicted, it did nothing. Solder suckers, they are awful. I'm better off just blowing on the damn thing. All right, one more go, and then we're giving up. More flux maybe? Don't even know where the flux pen is. I can't see. Ah, there it is. So I don't want to heat this up too much because I don't want to tear pads off the other bits. I'm just trying to drag the solder out of there, but no, you know what? We're not going to bother with that. So yeah, they are bridged. There's not much I can do about it now. So use a toothpick to separate the joint, flood it with flux. Tried flooding it with flux. I haven't tried a non-metallic object though. That is a good idea. Don't know if I've got anything that has a sharp point. Let's try some graphite. That doesn't take solder, does it? I don't think. Actually, does graphite take solder? Lead pencil. I've got one of those there, so let's try that. Let's give it a bit more. Well, looky, looky. Lead pencil has almost done it. Right. Okay, I think that's as good as it's going to get. Let's do some continuity between those pins. Let's see if there is continuity on anything that's important. I'm not really worried about the data line, so if anyone's got any idea as to what would happen if I connected the ID line to one of the data lines, let me know. But as far as I know, when I'm just plugging power in, I don't think it's really an issue. So this is continuity. I don't know if this is grounded, is it? No, so the case isn't grounded. Okay, let's poke in there. Okay, it's not connected to any, well, that's power and ground. So they're not connected, but they're connected by the circuit. So let's try power and this one. Let me just check that properly, sorry. I'm gonna have to get in here and I don't know if you'll be able to see. That's not connected. That's not connected. Okay, that's connected. That's not connected. So those two pins are still bridged. Let's see if I can scrape out the solder from in there. Do I have a knife? Yes. Ordinarily I wouldn't be too bothered about this this little solder bridge, but I feel like I have to perform for you guys, so let's just try and get in there very carefully. And no, I can even see the bridge and it's tiny, but I can't really do anything about it. Have I got anything small enough? I mean, I'm just in danger of doing more damage than I've already done. It's probably better. I should have done this before actually and cleaned it off. Out of focus again, isn't it? Of course. Well, that, oh God, it's such a tiny little bridge. This toothbrush could even break it off. Apart from it's got alcohol in my eye. Ugh, brilliant. Okay, let's see if, have I got a pin or anything? I don't think I do. How frustrating is that? It's all the way at the back of the pin, so that's why I can't get to it. Can I get to it with a knife. Do you know what I should have done? I should have just cut those pins off. I didn't need them. I only needed the 2 outside ones. Let's have a look at... oh, someone's already said that. Let's have a look at accidentally shorting the ID pin. Someone must have done this. Da, 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 da. I don't know. I can't find the answer on the interwebs, not very quickly anyway. So I can't actually get in there and cut them. It's a bit too difficult to get into that section and cut them. I don't have anything I can snip those with. Reboots the PC if you connect. Well, let's find out, shall we? Shall we connect it now? Let's put a polarized capacitor on the output first. So I need some capacitors. And I wanted a 10 microfarad capacitor, didn't I? So let's find something. That's 1,000. I mean, they're not organized, obviously. This is 1 microfarad. You never find the ones that you need. This one is 220. 10 microfarad. This one will be fine. That's polarized, so we need to remember which side is which. And the longer leg is the positive side. So I've already had this in a breadboard, which is why the legs are a bit weird. It didn't need to be a polarized capacitor really, but that's the one I'm going for. And there we go, and we'll just solder that on, and then we're just going to plug it into the USB and see what happens. Snips. Snip, snip, snips. Where are you? Just had... oh, they're right in front of me, of course. Right, that's a little bit ugly. All right, should we plug it in? This is going to be funny. Right, where did I put the cable? It was 2 seconds ago that I had it. There it is. Okay. Just in case this actually has any effect, this is going into a USB 3 port at the back of my computer. The one to the left didn't not fill with solder properly. It kind of looks fine to me. Looks like there's enough there. I wouldn't say it wasn't soldered. It's certainly still in there. So let's plug this in. So in theory, what should happen is we should get a little light on the board. If all goes badly, then the USB connector is going to make this explode. So if you're, you might be about to see something. Oh, do you know what I've forgotten? This. Oh, it's strong. That is stronger than it should be. Right, is everybody ready? Should I actually do this? I'm not sure. Doesn't really seem like a good idea just to plug this in, knowing that I've got a solder bridge. But we're going to go with it. To clean the flux, I'm using, it's just a bottle in a little spray thing of isopropyl alcohol, which cleans it off fairly well. It's still a little bit sticky in places, but it's okay. Oh, and a toothbrush. It's a Colgate toothbrush. Yeah, be careful everyone. Here we go. I'll bring this into frame for you. So there's an LED just here, and that should light when we plug this in. Oh my god, have I done it right though? Do you know what? We're going to check one more thing just before I do this. Don't use a PC. Oh, you probably shouldn't use the PC that I am currently streaming on. You're right. We'll use this little power bank, which is the one with the light on. I'll just turn the light off. There we go. You're right. That's a good plan. Yeah. Right. We're just going to check one more thing. Okay. So this is the this is our schematic. So what I want to do is have a quick look. I need to keep that. Let's have a look at USB pin out. I'll make sure that I've done it right. Micro, oh, it's mini USB connector. If this is wrong. Let's see if we can find one that's the right way up. I did put mini, didn't I? Yeah. So I'm just trying to find one that's the right way up. It's an awful lot of weird connectors on here. Oh, maybe I should put socket. Oh, I've spelt socket wrong, but it's going to correct me. No, that's the wrong one. Well, basically, it's the same as that, isn't it? Is it? That doesn't. Oh, that's mini USB VGA. I've never even heard of that. No. There we go. Pin 1 to 5. It's not actually helpful. Device. 1, 2, 3, 4. So pin 1 should be VCC, which it is, and then pin 4, or 5 in this case, should be ground. Yeah? That's a mini one just there, look, USB mini. We're just going to go for it now. Let's jump back to the desk and we'll see what's going to happen to this darn thing. Okay, so let's plug it into the high current plug on this. So this one has it's got 2 plugs, so we'll just plug it in there. Here we go. Actually going to go for it now. Well, there's some smoke coming out of the chip. I don't know if you can see it. I don't know what's about to happen, but can you see the smoke there? I'm not going to immediately unplug it. All the damage has been done already. I've done something wrong. See that smoke? It smells horrible. So let's unplug that and show you what's happened to that IC. You see it bulged out in the middle there? Still smoking. That is ruined. It's always something interesting, isn't it? Okay, well that wasn't all for nothing. At least I now know that I've done something wrong here, and I can kind of tell you what it is. That is because these are the wrong way round. I'm pretty sure that this one, which is, I don't know, I'll have to look at the foot. Let's open up the footprint. Open the device. So pad 1 is GS1. Can I connect that? I want to have a look at the package. Let's get rid of that. No, I didn't want to do that. Open symbol, that's what I wanted to do. So this on the board is the first pin we've connected to, and the first pin on mine is ground. So that's pin 1. Let's find out what it actually is. I'm pretty sure pad 1 is pin 1 on the USB. So that's G1 pin 1. Let's see. No, the star's in the right place. I've just looked at the thing. So if we look at pin 1 of the USB, is ground. Yeah? I think we're all down with that. Pin 1 of the USB is ground on my schematic. Yeah? And then pin 1 of an actual micro, well this one's micro, but it might as well be mini. It's the same pin out, is V, oh no, it's, hang on a minute, it is ground. I'm just reading it wrong. So that is right. Is it right? Or have I read this wrong way round? So VCC, you know what, let's connect something to, let's look at our board. Oh, look, it's back to front. So pin 1 is VCC, isn't it? I think. Flip. Hang on a minute. Do you know what? We can solve this by no, I think actually, yeah, look, that is freaking frustrating. What have I got that's got a micro USB? Anything? I got absolutely nothing. What I do have is, oh, it's fine. I've got another IC, and that was for this very reason. I don't need to use the USB connector. I can use a breakout, because that's obviously wired the wrong way around. But if you look at this USB connector, which pretty much demonstrates exactly the same thing. So the first pin on, where's a pointer? This will do. So the first pin over here is ground, and the first pin over here I assumed was power because I read it back to front. So yeah, let's say the board's backwards, not the connector. So I don't need to worry about this connector at all. I can just leave that plugged in. or not populate it, and we can start populating another board. So let's get rid of that. This is now going to be resigned to the old projects bin, and I've only been going for 2 hours, bloody hell, so we've probably got time to rush through one more and see if it works, I imagine. So I need another one of those boards now, don't I? It just so happens I've got one. So if you're all prepared to watch me do it again, this time I'm not going to stop and explain everything I'm doing. I'm just going to go through it. I think you guys distracted me there. I think that was it. But at least it wasn't boring, eh? That's important, right? So let's get the difficult bit out of the way first and solder another little chip, shall we? I can't even see them. They've disappeared. Oh, Mayday. I've misplaced them. No, there they are. Okay, well, is anyone up for watching all of that again? Nothing bad would have happened if I plugged it into the PC. The PC's got a current limit, so it would have just cut out. It would have just made a bing bong noise, and then that would have been the whole deal. The PC wouldn't have done anything too bad. So from what we've learnt with this one already, we need to use a bit of flux here. Oh no, get off the tape. And if this one goes boom, then, well. Do you know what flux is good for as well? It sort of sticks the chip to the board a bit. Let's make sure we have it around the right way. Oh, flip. Literally flip. Alright, that's the way around it needs to go. Well, I think it is anyway. Don't worry, that was me making a bang noise. Nothing's exploding just yet. Again. Right. Bit more on that pad. Not too much. That will do. It's probably a bit too much on that pad, but we'll go for it anyway. With the solder splash there. Not quite lined up. There we go, that looks good to me. If it will focus, that looks not far off, that's fine. I'm happy with that. A little bit more flux, I think, while the pins are in place. And then let's go at the other ones. I've just soldered the wrong side. The side that was already placed. Yeah, that's fine. There we go. Let's just spray that. A little bit of a solder bridge over here, look. You see that? So we'll just drag the soldering iron across there and take that off. I might need to use a little bit more flux, but it might just come off. Yeah, it's just come out. Yeah, that's cool. Okay, so in this one we're not going to populate the USB. Anyone got an idea of what resistor you want to use? Not resistor, what LED? Not enough whiskey. You are right, because it's gone cold again. Maybe I need. Big Clive did a review on a mains powered coffee heater, like for a cup, mug heater or something. Maybe I should get one of those. Right, we've got a couple of capacitors. I remember which one those were now. Those were 100 nanofarad, weren't they? Is that right, everyone? Yes, it is, David. And those look not like those. They look like these over here. They look like these ones. So we need a couple of those. We're going to storm through this now. So capacitor there and a capacitor over there. Okay. This will not take long. One there, one there. Oops. Mayday. Clever Clog's trying to be quick there. One and the second one. There we go, there's those two done. That took ages before, if you recall. Yeah, they look good enough to me. And then the resistor in the middle was this tiny little darn thing, wasn't it? Where are those? Just here. It was an 0805 when I needed 1206. But I didn't have one, so we'll just storm through it. I spent a lot of time talking last time, so we can do this nice and quickly. Fair old chunk of solder in there because I need it to hold on properly. Let's put it this way round. Have I done everything right? Yeah, I think so. Looks fairly correct. There we go. Done. And then we need to put on a 100k resistor on R1, I think. Yeah, R1 is 100k. And that is one of these, 104. So 104 is 10 with 4 zeros behind it. That's right, isn't it? Unless it's a capacitor, which it's not. Plonk a little bit of solder down on one of those pads. Get my tweezers out. I could put it on the pad a little bit more, but I'm trying to do it quickly, so there we are. You wonder what his mic is plugged into. Why does it not sound very good? It's not something I can change midstream, unfortunately. Okay, so what's next? LED. What color LED would you like this time? What did we go for? Let's have a look. I asked that before, didn't I? So green LEDs, red, red. I saw 3 reds, so we're going with that. Right, where are the red ones? Red is the color of danger. That should be that one there. We'll do a quick diode check on it to make sure it is red, because it's out of the packet rather than one that was already in there, so I can't be sure. And that way round. Yep, it's a red one, so we'll use that. You've got to admit, this whole process is a lot faster when I'm not talking the whole time. Okay, well that just didn't work, did it? It's because I was gripping onto the LED too tightly. There we go. Right, that's done. Now we need a 470 ohm resistor, one of these ones. Oh, hang on, they're 0805, so I don't want those. 1206. Okie doke, let's put a blob of solder there. What fabrication house made the PCB? This is from PCBs.io. They are my new personal favourite because they do black solder mask, and I got sick of the purple one and fancied a change. That looks a bit ugly. Not a problem though, because I blew one up already, so. Right, now we just need to put the polarized capacitor in. I have to see if I can find another one of those ones. It was 10 UF, wasn't it? Oh well, okay, there we go. I found one already. Now we'll just solder that in, and then we'll have to solder on some connectors to some pin headers, because we're going to have to put this in a breadboard in order to power it up. What word becomes shorter when you add 2 letters to it? It's probably short, I would imagine. You add E and R. But thanks for coming along to promote your channel. and good luck in your endeavours. Right, you should definitely try dirty PCBs. I haven't given it a go yet, but you should. Let's grab some stuff. What are these? Are these all right? How many do I need? 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6. I can't count. 7. I always end up with one extra on these. Ow. Perfect. Okay, now I like to solder these while they're inside a breadboard, so just pop that in. And then I need something to weigh it up. No, to lift it up off the breadboard a little. That will do. Not quite. Let's get something else. Nope. There we go, that looks relatively good. Now, I'm going to take that away and then we're going to manually adjust the angle here. That looks okay to me, good enough I think. And then these are super simple to do, so you can really rush through these. Maybe a little bit more solder on that one. You know, if you were at all worried about your health when doing stuff like this, you probably want an extractor fan. You can probably see how much smoke's coming off this, and I'm breathing it all in. But, you know, I'm drinking whiskey, so there's some kind of protection there. Okay. Right, we'll give it a quick spritz with the old isopropyl alcohol, and then we'll give it a little rub. Smells amazing. And now I need a way of getting the USB power over to this. I don't know if I want to solder that up. I guess we're going to. I don't know if do I have a micro USB? Yes, I do. Okay. Yeah, PCBs.io is they rely on Chinese manufacturers, so this time of year is terrible because we're coming up to Chinese New Year, or even if it might even be Chinese New Year now, I don't know. But that means everything you're getting from China slows down. So you'll find things do not get delivered very quickly. But you'll find that from OSH Park as well. It's not specific to any particular board house. God, the pads on this are horrible. They're just so tiny. Look at that. There we go. Finally. When they're really small like that, they don't take the heat very well, so no, it's not going to take that. I'll have to try again. Because I need to, there we go. No, I have to do that again. You see where it's bulging out a little bit? It just needs heating up a little bit more. There we go. So the heat doesn't transfer down to that pad very well when it's really small like that. That is good enough. So let's zoom out a little bit. I say zoom out, I'm literally lifting up an arm off this helping hands thing. So we've got our board there, and this is our ridiculous board. Also, I don't know if you noticed, but I printed these on the wrong way around, which is great. But good thing about that is I do have a broken one that I can refer to. So let's plug that in there, and then let's wire it up. I've got some jumper wires here somewhere. So ground is to ground. Stat out oh crumbs, where's the out minus go? I don't know. I'll have a quick look on the schematic. I'm pretty sure all out minuses, out plus, they're all ground, so it doesn't matter. So it can just go into any one of those. So stat is the first pin. No, it's not. That pin is ground because I'm having to read the focus. There we go. I'm having to read this upside down for you. I'm having to read this, but flip it over. So read that the other way around. So focus, please. There we go. So in minus is ground. In 2 minus is also ground. It's just so you have 2 separate grounds for 2 separate power supplies. So the next one along is into plus. So let's make sure we just plug that out somewhere over there. So we've got it out the way. And then in 1 plus goes to power on the USB. So VCC on the USB. And then we've got into minus, and that can come over here. Oh, no, I've done it wrong. Let's start again. So that way, stat out. Oh no, I had done it right, damn it. So that farthest pin is in minus, sorry, my hand's in the way, isn't it? In minus, and then we have out plus, no, into plus. God, it's really difficult to read the other way around. Into plus, so that goes there, and it can come over here actually, so it's out the way. Into minus is there, and then we have out plus, out minus. So what are we going to power? Out plus, that's a bent jumper, so let's be careful. Out plus, over here, and then out minus can be blue, doesn't really matter. And then we're leaving our stat pin unconnected. Okay, the moment of truth. Oh. Hopefully none of you can hear my neck cracking. Right, I need a USB cable that does micro. Look, nothing here is a failure. Look, it's 20 past 10, I can't stay up much later. I've got to go to work tomorrow. Right, let's plug this in. If this goes wrong, boy oh boy. Right, shall I just plug it in and see what happens? Or should I plug something into the output first of this? What are we going to plug in? An LED? Will an LED do? Let's have a quick look at the datasheet and see if there is a minimum current draw. It should have low standby current, low 840 milliamps, no. It doesn't appear to be a minimum output. Hopefully this is going to work. Or is there a minimum? No. I've got quiescent current, but that doesn't matter. The connector looks the same as you did. It sort of does, except for if we look at my board schematic, so we have, so yeah, actually we'll jump over to the desk. So the connector on the board has this one as ground. So essentially I've looked at this in a mirrored way. I've flipped it. So if I jump back again, so you'll see that this pin here is power on my board. And then if we look at the desk again, and I flip that round so it makes a little bit more sense. Oh, it's just wires in the way. You'll see that that one is actually meant to be ground. So I did just reverse the voltage on it. Silly. So now we're going to plug this in. Let's put something on the output. I need an LED or something. Have we got any? Well, I've definitely got some. It's just a matter of finding them. Let's go with a big old bright white LED, and I'll nick a resistor from over here. I don't know what value it is. I'm sure it's fine. A crusty old LED, and that can go there to there. And that can go there to there. Now let me just double check that we've got things wired correctly. So stat out minus, that's correct. Out plus, that's also correct. I'm just using this as a little guide. In fact, if I bring it up closer, you'll be able to see what it's not going to focus. So out plus, in minus. Well, they're not connected, so it doesn't matter. In 1, 2. In 1 is plus, and that one is minus. Okay. So, moment of truth. Okay, let's go for it. I've got my little connector here. This is going to my power bank. This might be, I mean, those chips were like £3 for 2, so in fact, let me just check what they were. I bought them on eBay, eBay UK as well, so they were in the UK. Purchase history. So they were, oh, okay. So they were £6.24. Did I buy 2? Hang on a minute, view order details. I wouldn't have spent £12. No. So they were £3.12 each. So we've already blown one up. So I'm not going to earn that much money on a video. So here we go. I'll tell you what, that connector is quite difficult to put into. So I'll put it into this one first and then plug it into the power bank afterwards. There we go. Right, plugging it into the power bank now. Okay, that didn't do it. Have I ruined my power bank? No. Something's gone wrong. Nothing's getting hot, but it won't power up. What does that mean? Oh, it's possible that it needs 2 power supplies, so let's plug something else in. I mean, at least it doesn't have that ground connected, so let's do that now. This again could be terrible. So I'm sure that one was ground, and I'm sure that one was positive. And I'm just using 4 batteries here. So, okay, so we've got power output with the batteries. And now I'm going to plug in, what I should have done was, well, let's just plug it in and see what happens. Now I can just turn off the LED. Okay, well, it doesn't work on the USB power for some reason. Now, is that because the voltage is lower than the battery voltage? No smoke, at least. Yeah. I think it's because the voltage coming in is lower than these batteries. So what I should do is I'm just going to get a different battery box. Crumbs. Oh, I almost fell over then. No one saw that. Everything's coming up watts today, isn't it? So I've got a 3-cell battery box instead, so we'll try that. You know that 100k resistor you put in? Yeah? What about it? So something wrong with that. Have you been looking at the data sheet? Yeah, I think the power banks basically don't like low current scenarios, so we might put a higher current on. What do we have that we can throw on there? Oh, I know, actually. I've got something. So this is ground and power. Okay, so that's on. Let's see. No. Okay, let's put something bigger in it. We're going to power up the matrix. Not the actual matrix, the LED matrix. Let's see, have we got wires for this? Yes, I can steal them off this board. Right. So I need power and ground, so we'll say that white is power and the other one is ground. So white is power and the other one is ground. Nothing feels hot at the moment, so I think we're good. Right. So this is powered up and so is that light. So that should be enough current draw for my power bank to say, hey, I've got to do something here. Except it isn't. Why on earth? Why would it be going wrong? What have I done wrong here? I mean, the chip's working, because if we look at the schematic, we have in 1, which is where I'm passing power to. In 1 comes down to in 1 on here, and then it has to go through the chip to go to out, which is where I'm pulling the power from, I think. Yeah, it is. So the chip's absolutely working, but changing from in 1 to in 2 isn't working. The VSNS truth table should work. So the truth table says if VIN, VSNS, is greater than 8 volts, and it's no in this case because it's grounded, it should use, oh yeah, and if in2 is greater than VIN1, which it isn't, it should use in1 rather than in2. And I'm pretty sure, because I've just switched over, well, it's not 5 volts versus 5 volts, I would imagine. In any case, even if it is 5 volts versus 5 volts, it would only change if VN2, so it would only change if this was opposite. So it says if VN2 is greater than VN1, if it's not greater, it will be in 1. If it is greater, it's in 2. So let's look at the multimeter and see what it says. But I'm pretty sure that 3 AA batteries can't be higher than a USB power bank, surely. So let's see. So I don't know if you'll be able to, oh, let me jump back to the bench, sorry. Calling it a bench, it's just a desk. So, oh, it's very hard for me to get this in shot, but that says 3.906 volts. And if I measure VCC on the USB, the power bank is connected, but I don't think any power's coming out of the damn thing. No, it's not. I mean, maybe the cable's duff. I'm just going to take that out for a second. Do you know what? Let's try a different power bank, because it's entirely possible I've blown that one up. Right, this one has at least activated, plus it's got a button that I can press, which is nice. So let's take that out of circuit for now. We'll plug this back in. No, it does not work. Right, well, that's something else to find out what's wrong with it, I guess. So, brilliant. Let's have a look at the schematic again. My word, I don't even know how many people are watching. I can't see that page. Or at least I'm not watching that page. How do you get to that page? View on watch page? Oh shit, I'm out of there.
What's wrong?
Oh, that's me. So, oh sugars, is it still going? Yeah, okay. I thought I'd pressed the wrong button there, guys. Right, so let's have a look at the schematic. So, let's have a look at the schematic and the data sheet at the same time. So output switchover response, test circuit, we don't need to worry about that. We just want the simple circuit, which isn't that one, or that one, or that one. It's probably just the one at the top, isn't it? Stat. Oh, you piss. The stat pin, probably. Let's see what the stat pin does. Stat is an open drain output that is high Z if the input switch satellites. In switch is on and out. Oh, I'm too tired to understand. It's an output, so I don't understand. That's not. Let's see what the inputs are, because I think that's probably where I'm going wrong, if anything. Input, input, enable. What's enable gone to? Do you think it might be that enable's gone to ground? Maybe. Hang on a minute. Enable is a TTL and CMOS compatible input with a 1 microamp pull-up. The truth table shown above illustrates functionality of enable. So enable 0 is correct. Okay, so it's meant to go to ground. That's right. So that's not wrong. And I'm worried about the stat pin, but it is an output. But on the on here, stat does not. Well, actually, stat can tell me via a multimeter what it is doing and sort of why, I guess. So let's have a look at it. It's only 3 AAA batteries are at 3.9 volts, and the USB should be. If I take it out of circuit, I should be able to power it up enough to read it. Let's just jump back to the desk quickly. I can't show you the multimeter at the same time, or can I? I don't know. Let's see. Let's just move all of my stuff over. Okay, that is upside down for you, but the right way up for me. So hopefully you guys can read it. If I just press on power for a second. For heaven's sake, come on now. It's very difficult to do this at the same time. No. You know what? I'm not getting anything at all from this connector. Let's just try and power this thing up from the USB. Let's not worry about that being in circuit. Let's just try and power this matrix up. So white is VCC in this case, and then this one is ground. There's something wrong with this connector. It's not powering this up. Flip. Should we try a different connector? I don't know if I've really got time to do this now. God, well, at least you, VCT pin is 1 off. What do you mean? It's soldered together, right? Is it not? That is connected. That is, it's not 1 off. It's definitely right. So yeah, that's not working, unfortunately. So let's get rid of that damn connector. Check the power bank still charges your phone. I don't actually have a phone. I tell you what, I can charge the other USB power bank. So this is the cable, and this is my other USB power bank. There's a little charging indicator there. So there we go. It is charging, so power's going through, but that connector is rubbish. So luckily I have some more. I don't know what the problem would be there. I can't detect any voltage on that connector at all coming from those pins, so there's something wrong with the connector. But I have some of these little ones, so we'll try one of those. And I'll need some more pins, but they're a little bit odd, so maybe just wires. Maybe just wires. Yeah, let's just do some jumper wires on it. Let's just steal some from over here. So the far side one is VCC and this one is ground. It says there, doesn't it? So I'm just going to solder some jumper wires onto this because I need it to be quick and dirty. So nothing special. Let's just hold that down with a pair of pliers. Super technical. Probably going to burn my pliers now. But I do not trust that it's going to work. Oh. There we go. Right, let's try that instead now. So we've got ground, which is grey, and power, which is white. So let's try this instead. We'll use the same cable because we know it charges the power bank, so and we get power. So it was that connector. So maybe plug it into the PC and don't trust the power bank. You know, I received some different advice earlier that said definitely don't plug it into the PC. So let's try this circuit again. Now that I think everything's correct. So we'll see. Power and ground. Okay, and this is voltage 2. That one goes in there. Oh, that one goes in there. Need to strip the wire a little bit more. Have I got proper strippers? No. Let's see. I have to try doing this manually. Oh, if anyone wants to buy me a pair of nice wire strippers, I would be very grateful. Ugh, come on. There we go. That will do. I've just stripped a little bit more off them, so they should slot in and stay there. Right, so it's on using that bit of power. And this is also on. Shall I get that over there? Okay, so you can see that. So you can see that's working at least. I prefer a different face to that. There we go. Now let's plug in the USB power and see if then I can disconnect one of the power sources. Okay, I think it's taking USB power now, because the USB power bank's staying on. What happens if I disconnect this? No, nothing. Oh, well, yeah, of course. I don't know if anyone's noticed, but I removed the blooming wires from over here, didn't I? So this one was ground, and this one was power. Look at that. We forgot about the little red light on the board, which told us what the status of the board was. That's some cold coffee there. So it might work now. Let's just pull out the battery. This is the battery lead. These are the batteries here. Ah, look at that. So it's still working on USB power. If I plug the battery back in, I've got the power bank just here. That's what it's plugged into. Let's unplug the power bank. And it's still working, but the power light on the board has gone off because we're no longer plugged into the USB. Boom! Thank you. It is actually done. I'm kind of amazed that worked, really. Let me just, I think it's going to have to be the end of the stream now, honestly, because I'm so tired. Let's just make my face a little bit bigger, not too big though. I'll plug this back in so you can see it's working. So red light comes on. We're using USB power from this power bank. If I unplug the power bank, which is currently powering this, and you can tell that because I can take the battery out now. If I plug the battery back in, then remove that, we're still going, but you'll have noticed a dimming in the lights. That's because we're running on lower power. Again, if I plug this back in, bit brighter because we're now running off the higher voltage. On and off. So power multiplexing without, I might add, disrupting the microcontroller. So let's put the microcontroller onto this pattern. Hopefully it's not going to disrupt the microcontroller, we'll see. If I plug that in, microcontroller is still going. We're now powering from the USB. So this is an 80 mega 328 on here. So the idea is it would power a microcontroller. Unplug it. Still going. So that's it. I'm ending the stream now. Thank you very much for watching. Thanks for sticking with me when I destroyed one of these. It was fun. I did sort of suspect something might happen, but there we are. I won't be giving out the schematic for this board until I fixed it. So I'll do a video at some point with the updated stuff. And I guess we'll do another stream doing a bit more soldering, because I never got to this USB matrix, which is the one down here, but I thought it might be fun to solder it on stream. So anyway, thanks a lot for watching. If you guys can click that thumbs up button thing, that would be great. Share or whatever. No one shares stuff. That's silly, isn't it? But whatever. I appreciate you being here. It's really nice, actually. And I think troubleshooting goes pretty well when you guys are here too. So thank you very much for not same time tomorrow, unfortunately. I've got to work on Saturday, so I can't be staying up late. Anyway, peace out. I'll see you all soon. It's going to take me ages to stop the stream, actually, so this is a bit silly to say goodbye now. All right, see you guys.